Okay, so this is lesson 4.2b on synthetic division. Yes. Is it frozen? Thank you. All right. So your instructional objective today is you're going to be using synthetic division and to do 3 different things today. The first thing you're going to do is use it to divide polynomials. The second thing you're going to do is find remainders. And then the third thing is you're going to prove that a number is an actual 0. So synthetic division can be used for multiple purposes. However, with your red pen, in this little section underneath step 6, let me just point something out. Synthetic division does not work in every circumstance. It's just like if I ask you to find the zeros of a quadratic. First, we try to factor because factoring is fast, but factoring doesn't always work. What always works when we're solving for zeros of a quadratic? Quadratic formula. Okay, so like when we're dividing polynomials, long division always works. But it isn't efficient or quick. Synthetic division, however, is, but it only works in this circumstance. So here's this. We're going to say this. Synthetic division only, all caps, only works if dividing by x minus c, a linear divisor, okay? And here's the thing. The other thing is the lead has to be 1. It has to be 1x minus some constant or plus some constant. So it has to be a linear factor where you can see the 0 right away. Right away. Synthetic division only works if I'm dividing by x minus c. That's it. If you have an x squared or a 2x minus 3, you cannot use synthetic division. You have to go to long division. All right, so step 1 in red. So again, I'm only going to color code on the first example, and then I'll just go to my pencil. Set up the synthetic division format. Use the opposite of c, because that's your 0, okay? And coefficients of each term. Don't forget to fill in missing terms with zeros. Okay, now I'm switching to purple. Step 2. Bring the lead coefficient down to the bottom row. Step 3, I'm going to do in green. Multiply c by the lead coefficient that was just written in the bottom row and place the product in row 2 underneath the next coefficient. Then I'm going to switch to blue. Add the numbers in column 2 and place the sum in the bottom row. And don't put your blue pen down. We're going to repeat steps 3 and 4, and step 4 is in blue. Then I'll go back and grab my green pen. We're going to do 3 and 4. And then I'll pick up my pencil, and I'm going to write my answer. So at the end, after we've done all this synthetic division, we're going to insert the variables, the variable, the x, and the exponents behind the coefficients. The degree of the quotient, or the degree of the answer, is 1 less than the degree of the dividend, which is the number we're dividing into. The last number in the row is the remainder. Okay? So here's what's cool about synthetic division. Synthetic division isn't even division. It's fake. In synthetic division, you multiply and add. That's what you do. You multiply and add. And you remove all the variables and exponents from the problem, and you just work with numbers. It's kind of nice. But here's what I want to do. Before I teach you synthetic division, we're going to go ahead and divide this problem over here using long division. Because here's what I want to do. I'm going to do long division, and then I'm going to do the same problem in synthetic division. I'm going to challenge you to tell me why synthetic division works and tell me how synthetic division works. Because if you can understand that it works, then you'll know when you can use it. So let's go and say, it says use synthetic division to find the quotient and remainder if the first poly is divided by the second. Well, first we're going to do the long division example because I'm asking you to compare. So quickly, in the long division, we would be doing x plus 3 goes into 2x to the fourth plus 5x cubed. Oh, there's no x squareds. So plus 0x squareds minus 2x minus 8. And here we go. We're going to do 2x to the fourth divided by x is 2x cubed. Can we close that door over there real quick? Because, wow, that class is loud. Okay, so we're going to divide. We're going to multiply now. So we divided. Now we multiply. So that's 2x to the fourth plus 6x cubed. And then we go in, and we subtract both of those quantities. So that cancels out that term and leaves us with a negative x cubed. Bring down the 0x squareds. And we start over. And we go, all right, negative x cubed divided by x is negative x squared. And we multiply. So that's negative x squared times x is negative x cubed. Negative x squared times 3 is negative 3x squared. And now we're going to go in and subtract. So we'll change that sign and change that sign. And we get 3x squared. Bring down the 2x. And we do it again. So 3x squared divided by x is 3x. So positive 3x. And we multiply. So 3x squared plus 9x. Now that we've multiplied, we subtract. So we're going to go change our sign. So minus, minus. Cancel. That's negative 11x. Bring down the minus 8. Last step. Negative 11x divided by x is negative 11. So that's negative 11x minus 33. Last step, go in and change the subtraction. Or we're going to change it by subtracting negative 11. That's plus 11 and plus 33. And we get a remainder of 25. And we're going to stop there. I'm not going to write out the full, proper version of that solution because I wanted you to see what the remainder is. Also, so what we're going to do is we're going to use synthetic division right now to find 2, negative 1, 3, negative 11, and 25. So we're going to find all these coefficients, 2, negative 1, 3, negative 11, and 25. And here's how it goes. Pick up your red pen. So synthetic division goes like this. Here's the format. You take and you make a little box like this. And inside that little box, you put your opposite of C. Opposite of C. Or the 0 of your linear factor. Or your linear divisor. So what is it? Negative 3. We're going to use a negative 3. Over here, look, we used a positive 3. But in synthetic division, we're going to use a negative 3. We use the opposite of that term right there. All right, now we want only the coefficients, no variables. So my first coefficient is 2, then 5, and then I have to put in a 0 because it's missing an x squared, then negative 2, and negative 8. And that is row 1. And this right here, where the 2 starts, this is column 1, column 2, column 3, column 4, column 5. And then we're going to do row 2. And row 2 is empty right now. So we'll leave it empty. And then we get a row 3. And at the end of row 3, we're going to make a little box. And this is where our remainder will go. Okay, so that's the format. That's how you set up your synthetic division. One more time. You take your divisor. It's in the right format because look, it's linear. It's x minus c, and the coefficient of your x is 1. So that's perfect for synthetic division. Use the opposite of your c, which is -3. I'm going to pick up my purple pen. And step 2. Step 2 says you bring the first lead coefficient down to row 3. So there we go. Bring it down. Now I'm going to go to my green pen because I'm on step 3. All right. So here's what you do. You're going to multiply your C term times the number you just brought down. So -3 times 2, and then you're going to put it right here under in row 2 under the next coefficient. So -3 times 2 is -6. Okay, now have your green pen and your blue pen just out because you're going to go back and forth between them a lot. Okay, now here's what we do. Now that we've filled in column 2, I'm row 2 here, we're going to add 5 plus -6, which is -1. Okay, questions? All right, I'm going back to my green pen then. And we go do it again. Now we're doing -3 times -1, which is +3. And we're going to stack it underneath the next coefficient. Then we switch to blue pen. And we are going to add those two numbers. 0 plus 3 is 3. Back to green. Multiply. -3 times 3 is -9. Then you're going to go grab your blue pen. You're going to add those two numbers. -2 plus -9 is -11. Green pen one more time. Now we're going to multiply. This is the last time you got to go back and forth between colors. -3 times -11 is 33. Grab your blue pen for the last time here. And you're going to add those two numbers, and you get the number remainder, 25. What? We didn't have to divide one time. That's so nice. Now, how do we go about writing our answer? Now, it says in step 6 over here, it says that the degree of the quotient is 1 less than the dividend. So what is the degree of my dividend? My dividend, what's its degree? What's my degree? The dividend, this number right here. Is x to the 4th, so it's a degree of 4. So my answer is a degree 1 less. And that's because basically I did x to the 4th divided by x to the 1st. X to the 4th divided by x to the 1st is what? X cubed. So here's what we have. 2x cubed minus 1x squared plus 3x minus 11 plus our remainder, 25, over our divisor, x plus 3. And that is synthetic division. Now, I'm wondering if you see a connection between the two. If you see things that happened over and over again. We used a -3 instead of a +3. So because we used a -3, did we have to do a change? No. Do you see the -6? It's right here after the change, right? And then you see the -1 right there. Yeah? So -6, -1 stacked right on top of each other. Do you see the +3 and the +3? Right there and right there. How about the -9 and the -11? Right there and right there. And then the 33 and the 25. Right there and right there. But instead of that problem coming down in this diagonal and taking up all your space, you're keeping it all in this space. And because you use the opposite of C, you don't have to do a change. It's kind of interesting. And it's nice that it works out like that. Now, sometimes people will ask me after I teach this lesson, Mrs. Frame, I still don't understand where to put the exponents. What do I do? Here's what I'm going to tell you. The last row is your remainder. Column 4 or the row that's right next to it is your constant, so no x. This one's your x to the first, this one's your x to the second, this one's your x to the third. So sometimes I'll just work it backwards. I'll start on remainder, constant, x to the first, x to the second, x to the third, so I know what variable, what exponent to put in. And I know when to leave no exponent on my constant, no exponent on my remainder. So any questions? Okay, so that's one thing synthetic division is really good for. Synthetic division is also just really great for finding remainders, right? We found that remainder. We compared our two remainders right there. So in this situation, this problem here, it says use synthetic division to find the value of the polynomials. If f of x is equal to 3x to the fifth minus 38x cubed plus 5x squared minus 1, use synthetic division to find the f of 4. Now, on Friday, we used the remainder theorem to find the f of 4. Okay, so if the f of 4, if I was really using synthetic division, what does this 4 stand for? What is it taking the place of in my divisor? X. Is it minus 4, right? Wouldn't it be x minus 4 would be the linear factor that it's taking the place of? Right? So that's your linear factor. So basically it's wanting you to use synthetic division to divide those two things and find your remainder. Okay? So here's what we do. I'll do my format setup in red, but then I'm just going to go to my pencil for the rest of it. So we're going to take 4, not negative 4, because it says we're going to find the remainder of 4. So we're going to plug in a 4, because our 0 would be x minus 4 for that one. And we're going to put out our coefficients. So let's put it out without skipping any zeros or any exponents. So what's my next factor, or my next coefficient after 3? 0, then negative 38, then 5, then 0, then beautiful. Row 2 is empty, and row 3 has got your little box for your remainder. Okay, so I'm going to my pencil, and here we go. Bring the 3 down and begin. 4 times 3 is 12, and add. 0 plus 12 is 12. 4 times 12 is 48, and add. Negative 38 plus 48 is 10. And 4 times 10 is 40. And add. 40 plus 5 is 45. And 4 times 45 is 180. You got it. And 0 plus 180 is 180. Now I'm going to be really impressed. 4 times 180 is? Woo! That is right. It is 720. And add 719. Therefore, the f of 4 is 719. And I think that that really does illustrate the remainder theorem, because look at what our remainder was. So let's compare it to the remainder theorem. Because remember that I've told you that you will be using the remainder theorem on your test. You will also be using synthetic division. But let's compare it to the remainder theorem that says I can just plug the 0 into the problem. So what was it? 5 times, or is it 3? 3. Sorry, that's a 3. Times 4 to the 5th minus 38 times 4 cubed plus 5 times 4 squared minus 1. Just plugging it in. And guess what you get when you plug all that into your calculator, because I don't want to do that by hand? 719. And I wonder which one's more efficient in the end. I mean, if you were doing this by hand, I bet synthetic division would go faster for you. And it's an option. But it's interesting how there's multiple ways to prove something. Basically, in that situation, you were just finding the remainder. Yes?
On our test, will we be allowed to calculate?
Yes. All right, last problem. So we've used synthetic division to divide. We've used synthetic division to find a value or a remainder. Now we're going to use synthetic division to prove that a number is a zero of a polynomial. So here's what I'd like to write before we begin, and let me get this into the screen so it's in the video here. All right, so we're looking at this problem right here. Here's what I want to say. If negative 11 is a zero of f of x, then the remainder will be what? You got it. If it's an actual factor, and negative 11 should be a factor or a zero factor. I can spell words sometimes. I'm just going to do that, and that'll just fix that up real quick. Okay, so if negative 11 is actually a zero of f of x, then the remainder will be zero, and we can use synthetic division to prove it. So I'm going to grab my red pen just to set it up. So here we go, negative 11, because remember, if it's a zero, then it was x plus 11. If negative 11 is a zero, then it's linear factors x plus 11. Okay, so am I missing any exponents here? 3, 2, 1, none, so no zeros. So 1, 8, negative 29, and 44, gathering up all of our coefficients and dropping all the variables in the exponents. Row 2 is empty. Row 3 has our little box for the remainder. Grab our pencil up, and here we go. Bring the 1 down and begin. Negative 11 times 1 is negative 11. 8 plus negative 11 is negative 3. Negative 11 times negative 3 is 33. Negative 29 plus 33 is 4. Negative 11 times 4 is negative 44. And 44 plus negative 44 is 0. Therefore, negative 11 is a zero of f of x because there was no remainder. And there you go. This is synthetic division used in 3 different ways. Your homework, as I mentioned, well, I'm going to just put it in the video for the people that weren't here, on a lesson on the assignment 4.2 in Canvas, 21 through 27, 29 and through 30, and 35 and 36. You do have a quiz on Wednesday.